A lot of demonstrations are meant to demonstrate the density of gases, and here's one that I really like. It's so simple. We're going to take these fancy high-tech beakers, they're actually just cut-off soda bottles, and a little chemical reaction. We've got baking soda and good old vinegar. Whoop. Little is good, more is better. That's why I always say. We have evidence of a chemical reaction right there. A gas is being produced. And if you know what gas that is, if you didn't, I might help you with telling you the active ingredient. In fact, the only ingredient in the baking soda is sodium bicarbonate. Carbonation, that's carbon dioxide gas. And the bubbles of it form, and where do you suppose that carbon dioxide is by now? Out in the room? You might think so, especially if I do this with my hands, but turns out it's not. We're going to find that out in a second. I've got a candle on the end of a wire here. Let's get my little carbon dioxide tester, and we're going to do a control here. First, I'm going to put it in this other beaker that has not had any carbon dioxide produced in it, and see that as you put it down in there, it continues to burn. Out here, there's air. In here, there's air. But over here on this side, we get a different effect. So apparently the carbon dioxide is still in there. It's almost as though we're sitting in there like a liquid. It is a fluid. That's important to point out. Fluid, anything that flows, liquids and gases are both fluids. But this gas is behaving like water. It's staying down in there, and that's because it's so dense. Carbon dioxide is about 50% denser than air. If it is sitting in there like a liquid, you suppose I could maybe pour it from one container to another like a liquid. Well, it's worth a try. So here we go. And again, I'm pouring just the gas, not the vinegar and baking soda mixture that produced the gas. That's one of the reasons I left the top of the beaker curved like that, so I can get it every last little bit out there. So, was I successful just now at pouring the carbon dioxide from there into there? It looks like I spilled a little bit there. Couldn't really see it. Well, here's the proof we want, right? We saw the carbon dioxide was in there, and now it's not. Actually, got a little bit at the bottom still, okay? But the question is, did it actually make it over into here at all? Let's find out. Oh yes, definitely. So I was successful just now at pouring the carbon dioxide from here into here. The other thing you can do with this demonstration is just pour the gas directly on the candle. Of course, you have to do it kind of quickly and just pour it out like that. But I kind of like the doing it here and then pouring it. You don't really know if it's been poured or not. So gas being poured from one container to the next. Now, I've got a similar demonstration I'm going to do over here and come back to this just to illustrate how dense the carbon dioxide is. I'm going to put some baking soda in there and a nice amount of vinegar. How full do you suppose this is right now with carbon dioxide? Well, one way to find that out is with bubbles. It helps if the bubble lands in the tank. There we go. Whoop. So I just generated a little layer on the bottom that bubble is kind of hovering on. Let me see if I can get some more bubbles in there. There's another one. So levitating bubbles, a nice little demonstration of it. That CO2 sitting down in there like a layer of water, a layer of liquid, and that bubble just kind of floating on it. Because that bubble is full of air, which is going to be more dense than the surrounding air because of the soapy water, but it's less dense than the carbon dioxide layer. Now, back to this. You saw me pour the gas from one container to the next. Do you suppose it would be possible to siphon it across? A lot of students won't know what a siphon is. You might have to demonstrate that first, but this is a siphon. Pretty easy. How do you use it? Well, first let's make sure that we have this reset. We have this thing empty of CO2 or full of air. No, remember I dumped it, but I didn't dump it all out. By the way, if I just left it in there, diffusion would eventually take over and probably 10, 15 minutes from now, there'd be no CO2 left. So here, I've reset it. We got that there. And I can tell in my reaction container that there's still plenty of baking soda on the bottom, but the vinegar needs to be replenished. So let's generate some fresh CO2. Okay, I think I have a full beaker's worth now. We can confirm that. It's nice to have this little tester here to see. Okay. Every now and then, by the way, if you get a nice fresh interface, it's possible to lift that flame off. There, I just did it. Ooh. There. I don't think I got caught enough, but the flame is actually being lifted off, and then it can relight. So it's a nice sharp interface of carbon dioxide and air. Let's siphon. Okay, we ready? You saw me pour it. Let's try to siphon it. Now, a couple things about a siphon. One is you have to siphon downhill, not uphill. So I have to raise this one above the other one. And you have to prime it. Okay, so here we go. I'm putting this tube down to the bottom of the CO2, but it's not into the liquid. Got to be careful about that. Okay? This is the most fun part of this demonstration. Lovely. Okay. So, this is one you kind of have to just wait on. If you think it's kind of boring to see it being poured, being siphoned is especially not interesting. But I'm going to tell you a good joke here. So these two sodium atoms are walking down the road, and all of a sudden one of them says, "Oh my gosh, I lost an electron." The other one says, "Are you sure?" The first one says, "Yeah, I'm positive." Get it? Positive? Okay, anyway. I better tell one more joke. This is siphoning pretty slowly. Neutron walks into a bar, orders a drink, gets a drink. How much are you, bartender? Oh, for you, no charge. Neutrons don't have charge. Okay, so here we go. That was a little stalling. And look, I'm doing like this as though something's dripping off of there, and I think it is, but I can't see it. Was I successful at siphoning the CO2 from one to the next? Let's find out. Okay, here we go. Remember, it was filled to the very top. I don't think I got it all. I'm thinking maybe it'll go out right about halfway or so. Look at that, right there where my finger was. Which means I should probably have about that much in here as well. Let's see. I'm guessing right about here. Oh, okay. So I siphoned about half of it in that joke. So it was siphoning pretty slowly. That's a fun demonstration to do. Let me empty this out. And all that time you were not really seeing the carbon dioxide produced. You were kind of believing it was there, but seeing is believing. You saw the flame go out. But wouldn't it be great if we could do this demonstration again, actually being able to color or mark somehow where the CO2 is? Well, of course you can. I'm going to forget that that's baking soda and vinegar. It's true that there's some leftover water in there. And I've got some dry ice here. And remember, the dry ice is solid carbon dioxide. So I'm going to put a few pieces in here. And now you're actually going to be able to see what you couldn't see before. It was filling up with carbon dioxide. Now that carbon dioxide is being colored. What is the coloring? What is that white mist? Little tiny droplets of H2O liquid that are condensing like clouds and even spilling over. And there was a spilling over like that. Then you saw me put the thing in here, still burn, and you saw it go out here, of course. Then what did I do? I poured it. And watch what happens as I pour it. It definitely ends up in there, but notice how it's not nearly as concentrated. That's not pure CO2. I haven't really gotten rid of all the oxygen, but I have gotten rid of enough of it to put out the flame. So, and then you saw me dump it directly on the candle. There it goes, poured it out. And then, let me get this all gone. You saw me siphon it. So here we go. See if you can see some of it coming out my mouth. Again, it's not starting yet, but has to be primed a bit there. And now I went and told you a couple of very corny chemistry jokes as we waited this for this to siphon. But you can see, if you get a shot of this lower beaker, the dry ice mist, the carbon dioxide gradually filling it. And now it is feeling pretty pure. So what ended up in here was much more concentrated because I'm delivering it right to the bottom of that tube. instead of having to pour it through the air. And here's kind of a neat effect. It's about maybe a third filled. I can go like this now, and don't have to prime it because the tube is filled with the CO2. I can go like this, and it actually is siphoning back slowly. I wasn't kidding when I had to tell 2 jokes to get half of it to siphon across. Okay? Is that showing up there as going down in there? I think it is. Okay? So, a couple of neat demonstrations there involving pouring and siphoning a dense gas.